Why don't we take a look at our packet? Today, with day 5 and 6, we really are not doing anything new. We are using the same skills that we've already learned, and we're just going to continue to practice them. Now, I will say, well, you guys tell me. Let's back up for a second. What are the two ways that we've learned that we can solve the equations that we've looked at? What are the two different methods? Yes. Faith. Yeah, simplify the fraction. Or we'll say combine. And then do what? After you combine that fraction? We'll say these are problems that have an equal sign in them. Yeah, then we can cross multiply. Good teamwork. What is the other way that we've talked about that we can solve problems? Yes, Ryan. We will use factoring. Yeah. Yep, that's a skill we would use, but I wouldn't consider that one of the methods to solve these. Yeah, Faith?
I don't remember what it's called, but when it's like the denominators are just regular numbers with the x.
Yep.
I don't remember.
Yeah, we clear the fractions. Now, Faith made a good point. She said when we have cleared the fractions so far, we have looked to do that when we have denominators that are all numbers. Now, today, with the problems that we're going to look at today, there are going to be questions that have denominators that are not just numbers, but clearing the fractions is going to be our go-to to solve today with day 5 and 6. And you'll see what I mean in the example, one of the example problems that I show. But up to this point, I have said it's probably easier to simplify fractions and then cross multiply. Today, with the problems that they give you, a lot of times it's going to be easier to clear the fractions. Okay, and you will see why in the example that one of the examples that I give. Before we look at that, let's look at number 7 on page 7. Does anyone have an idea of what we would look to do first to try to solve 4x? Well, let's say we're trying to, I'll be more specific. Let's say we're trying to combine these two fractions and then cross multiply. Aaron? Oh, okay. Your hand went up really quick and then it went down really quick, so that's okay. If we look at the denominators, these are very similar, aren't they? What could we do to maybe rewrite rewrite this one so that we have a common denominator? Yes, Trey?
Multiply it by the 2x minus 3 to the other one?
We could go that route to multiply each one by each other. What could we do that might be a little easier? Faith, how many times have I called on you? Twice?
Yeah.
Levi's got once? Okay.
Take the negative out.
Yeah, in a way we can take the negative out.
So like negative times 2x plus 3.
Can't you just do that by -1?
Yeah, I think you guys are saying the same thing. Technically we are factoring a negative out of this denominator. So if we have 7 over 2x minus 3 plus 3 over... Aiden, welcome. Go ahead, take a seat in our new arrangement. 3 over... Now this is a negative 2x and this is a positive 3. So we are going to factor a negative out and we are going to write it as 2x minus 3. So you could think about it as multiplying by -1, but I think it's a little easier to think about it as just factoring out a negative number. If we were to distribute that negative on the bottom, we would still get a negative 2x, because that's its original value. We would still get a positive 3, which is its original value. But we just wrote it in a way that works well for the other denominator. Now, if I were to fully rewrite this, it would look like this. This minus sign would be here. right? I can scroll down. Now we can write this as one fraction. And we can cross multiply. Okay, so that's one thing to watch out for, not just today, but in general. I think there have been 2 or 3 problems like that so far where we just need to rewrite one of the denominators and pull out that negative. Questions on that? Hello. Take a seat. New seats. You can come right here. Yeah, if you want to, Emma. Oh, I didn't think you actually would. Sweet. Welcome to the front row. We're just going over number 7 in the packet. Well, now we're going to go over a different one. We just finished number 7. Any questions on that? Okay. Now here's more like what you'll see today. A question like this. Now, what we could do is we could work to try to get a common denominator on the right side, and then we could cross multiply, right? We could do that, no big deal. That would be okay. The strategy that, and maybe not even in this problem, it'll be the absolute easiest, but for the most part today, and I'm going to show it, the strategy that I'm going to show is to clear the fractions. So if we take x plus 1, how could we rewrite that denominator?
3 times x minus 2.
Yeah? Agree?
Couldn't, well, I don't know that, but the 1 over x minus 3, couldn't you just multiply the bottom by 3 and equal over x minus 6?
You're talking about here?
If you went like x minus 1, if you multiplied that by 3, x minus 2, I mean, the other side of it.
X minus 2. Oh, right here.
Yeah. If you multiply that by 3, wouldn't it be 3x minus 6?
Yes, and we're going to get to that in just a second. You're going to see that. If we factor a 3 out of here, like Faith was saying, we're kind of getting at, we've got similar terms here. Now, what common denominator do we see that we could get all of these to? Pretty easily. Yeah, they'll have an x minus 2 involved, but what else will we need? We've got a 6 here.
3.
Well, we'll need to go a little larger than a 3. We'll need to go to a 6, right? Because we can't take this 6 down to a 3. We're going to have to bring... What are you guys waving at somebody? Oh, okay. Are you coming up with a dance? Oh. Oh, Gabby said yes. Oh, okay, cool. Hopefully it's to help you remember how to clear fractions. If we know that our common denominator is going to be 6x minus 2, we want to look to see to how we can get each of these fractions to have that denominator. So what needs to happen? Let's start on the far right. What needs to happen to that fraction so we get to our least common multiple here? Yeah, multiply by 6. So by 6, by 6. What about the second term here? Yeah. What about with this last term on the left side? And you multiply by 2. Now, I know that I did what was necessary to get a common denominator. So what you'll see on the key is I cancel out that denominator, and now if we look at all of our numerators, we have 2 Yep. Yes, we will have to. Or try to factor it by hand or graph it or something.
Yeah. I think the other way looks a little bit easier. For me personally.
Yeah. I mean, in this case, even though there are x's and other things involved, we still found the least common multiple of these denominators. The reason that I think this might be easier if we can get the hang of it instead of cross-multiplying is because when we cross-multiply, we'll have 3x minus 6 on the bottom is equal to, and we would have 5x squared minus 10x. And to cross-multiply these, that's quite a bit. I don't think so. Maybe. But we could use our brains maybe a little bit more, and then we could clear the fractions. But worst case scenario, you get on a test and you don't know what to do, you better combine those fractions and cross-multiply and figure it out. But this might be a little easier strategy. Now we can solve this. I stalled long enough. Plus 2 equals 5x squared minus 10x plus 6. We see we have an x squared and an x, so we're going to have to get everything set equal to 0. Now, I've got the, that looks like a fish. I've got the key right here, and I factored this out earlier, but if I were you and I saw this, I totally would put that in my calculator and look to see where the zeros are at, or I would use the quadratic formula. I think this would be, I mean, you can, but I think this would be pretty tough to factor by hand. But you can try it. So x would equal, if we swoop,
There it is.
there it is, 2/5 and 2. Negative what?
It won't be -2.
No, it's the opposite.
Right. 2 would make this 0. Sure, that's okay. Now what is the other way? Oh, yeah. Now what's the last thing that we have to do? We have our 2x values. What do we have to do, Ryan? Yes. Yep, these are our two. Out of these two values, are there any values that x cannot equal 2/5 or 2? Don't look at me. Look at your paper. Look at your paper.
2. Negative 2.
Well, just out of our x values.
2.
Yeah, x could not equal 2 because we have an x minus 2 on the denominator of one of our fractions. So if x were equal to 2, that would zero out and it would be undefined.
Oh, yeah.
So we need to cross out, we need to check our answers and cross out 2. I think those were the only two problems I had, yeah. So my point in showing these, like Trey said, you totally can combine the two fractions on one side and cross multiply. If you know that's your go-to and you feel good doing that, I mean, all the power to you. I do think, though, and what you'll see on the key today, that with these problems that we're looking at today, it will be simpler for most of them to clear the fractions, okay? Now, there are a couple where it would be easier to just combine and cross-multiply. And part of what we're working on today and tomorrow is recognizing the type of problem that we have and what strategy we want to use to try to solve it. Do we need to factor some things out? Do we need to clear the fractions? All these different things that we've talked about. So you might get done doing a problem and cross-multiply, and see that it takes a little bit longer, and then check the key and see that I cleared the fractions and how maybe it went quicker by clearing the fractions. And that's just kind of part of learning, of maybe doing it the long way one time. All right? So what that means for the rest of today then is that we are just